So you want to do something like find the gradient and the y-intercept of the line 7x plus 3y minus 6 equals 0. Well, the gradient is just the steepness or the slope of the line, and the y-intercept is where the line of the graph goes through the y-axis. This is a straight line because the powers of x and y are just 1. If there were squares or cubes in there, we'd have some kind of curve. But the general equation of a straight line is y equals mx plus c, where m is telling us the gradient and c is telling us the y-intercept, where the line of the graph goes across the y-axis. But clearly this is not that form. But it would be helpful if we could change this into that form, and we can. So if we leave the 3y on the left-hand side of the equal sign, that's the 3y here, and we move everything else across to the right-hand side, then we'll get closer to this form. So if we take away 7x from both sides, then the 7x will disappear from the left-hand side but turn up as minus 7x on the right-hand side. And then if we add 6 to both sides, well, it'll disappear from the left-hand side and turn up on the right-hand side as a positive 6. But we don't want to know what 3y is. We want to know what y is. So now if we divide right through the equation by 3, if we divide 3y by 3, then we'll have y. If we divide minus 7x by 3, when we have minus 7x over 3, and plus 6 over 3. And we can tidy that up. Y equals minus 7 over 3x, leaving that the same, but plus 6 divided by 3 is just 2. So we've rewritten this equation here as this. The great thing about that now is we can see the gradient is minus 7 over 3 because it lines up nicely with that in that y equals mx plus c form. And we can also see that our y-intercept, c, is positive 2. And I've graphed this. So I've used the original graphing, 7x plus 3y minus 6 equals 0. You remember the first equation of that line that we were given before we changed it into our y equals minus 7 over 3x plus 2. And can you see that the y-intercept is indeed at 2 on the graph? We've got a nice negative gradient coming down the page left to right. And the only thing left to check really on this original equation of the line is to see if when we've changed the form, we've got the gradient right. So what this is telling us is that if we draw a triangle on this graph, and we'll go and do this in a second, we should be coming down 7 for going up 3 on the scale. So if we go across and have a look at that, can you see that here, and we could do this anywhere on the graph, but I'm just trying to find somewhere that's easy to show this. If I come down 7, so minus 7, remember, if I come down, I've come down 7, so I've gone down from 9 to 2, so down 7, minus 7. To get back to the line, I would have to now go up 3. So I've gone in a positive direction 3 and I've come down 7. So you can see that my gradient is indeed minus 7 over 3. And that's exactly what we got here when we rewrote the form of the equation. And clearly it is going through 2 on the y-axis as the y-intercept. So that's how we would find the gradient and the y-intercept of the line 7x plus 3y minus 6 equals 0 by changing to y equals mx plus c form and then spotting our gradient and our y-intercept. So there we go.